find the rectangular and polar form of a conic given that its center is 5, 0, one of its vertices is 11, 0, one of its foci is 0, 0, and that it is rotated x degrees about the origin, and that tangent of x is 4/3. Because the foci is closer to the center than the actual vertex, its eccentricity is going to be less than 1, making it an ellipse. Also, it can be determined. It's 5/6. The distance from the focus to the center is going to be 5, and the distance from the vertex to the center is 6. From this, we can quickly find the polar form of the equation, which is once again represented by this formula, our polar formula. R equals A, 1 minus e squared, over 1 minus e cos theta, where e is the eccentricity, and A is going to be the length of the longer side. A equals 6, E equals 5, and so E equals 5/6. This results in the following. And after you do the simplification, in which case you just multiply everything by 6, you get this. To rotate it by x, we have to know the angle. Tangent x equals 4/3 equals arctan equals x equals 53.1 equals the angle of rotation. It could easily be the other angle. It could easily be another angle because many values of tangent can help you get 4/3, but we're going to stick with this one. We're going to stick with the one in the first quadrant. So we get this equation, minus within the cosine parentheses, because it's counterclockwise rotation. If this was a clockwise rotation, this would be a plus. Now, for the rectangular equation, we've gotten all the details we need. The semi-major axis is horizontal and it's 6 long. The foci are 5 away from the center. From this, we can use a Pythagorean theorem and find the semi-minor axis, which is going to be the square root of 36 minus 25, or the square root of 11. From this, we can get the rectangular equation of the unrotated ellipse. And after that, we have the unrotated form. We want to get this into the rotated form. So to do that, we have to first multiply both sides by 36 times 11 to eliminate the denominators. Then we should FOIL out the parentheses. Then we substitute any place we see x and y with the following angle rotation formula. In this case, since tangent theta equals 4/3, we can conclude, using the right triangle that gets made here, that sine theta equals 4/5 because it's opposite over hypotenuse. The hypotenuse is going to be 3 squared plus 4 squared. The square root of 3 plus 4 squared, as we all know, it's 5. And the opposite is 4. The adjacent is 3. So 4/5 and 3/5. We then substitute x and y in where we can. And we take this. Remember that we know that cos theta is 3/5 and that sine theta is 4/5. Then we expand. After combining like terms and also subtracting both sides by 396, we get this equation. This is the equation of the rotated form of the conic.